Okay, the next thing we're going to do is learn how to put all these pieces together to do some really cool input validation. So let's say, for example, right down here, I want to prompt somebody for their age. But if they screw up, I just want to ask them over again the same question, okay? So I'm going to put this in a loop. So when I ask them for the age, if they put in hello, well, then I want that to just continue asking them. Or if they put in 4,000, I want to just continue asking. So I want a loop, but I want it to happen at least once. So which one of the loops would do that? The do loop. So I'm going to have a do loop here. Okay. And so I need a loop control variable that says, are we done? Okay, are we there yet? So I'm going to create me a Boolean variable, and Boolean is just a cool term for yes or no. So I'm going to say, I don't know, how about, are we done? Are we done is equal to false, which means we ain't there yet, right? Okay, so I want to keep doing, so while are we done is equal to false. Remember, keep going until we're done. So are we done? If the answer is yes, well then I want you to stop. If the answer is not yes, I want you to keep going. That makes plenty of sense to me. Okay, and I need a semicolon here because that's the easy thing to remember. All right, so what I'm going to do here is first I'm going to prompt the person for their, for their age. So that's same old. System.out print without the ln. And I'm going to say enter your age. Okay, and then I'm going to go here and do, I'll tell you what, let me create a variable up here called int age. I'll go ahead and give it a 0 to start with. All right, here we go. So I'm going to say age is equal to integer, parse int, keyboard, next line, do it. Okay, so now I want to test this whether or not you gave it legitimate values or not. So let's do that. So I'm going to say if the age is less than some value which is legitimate. So I'm going to say something like age is equal to 0 or age is like greater than 140. Okay, that's a reasonable range. So if it's less than 0, if you put in a -4, I want you to say, no, that ain't right. If you put in a greater than, 150 or something, I go, no, that's probably not right either. So this is the range of values that are legitimate. Okay, cool. Now, I don't like what's called magic numbers. Like, where'd the 140 come from? So there's an easy way you can solve that problem by making those guys constants. Now, I like constants to be up at the top of the code. Now, you don't have to do that. I'm just saying I like it that way. So I'm going to go ahead and create me a constant integer, and I'm going to call it, how about min age equals 0, and then create me another one called max age equals 140. That way, when I see the 0 and the 140, I'll know I can read it, so to speak, and figure out what the heck that is. So instead of just being 0 out there, I can go ahead and see that this is min age. Now I can tell what's going on. So it's more important to know what that variable is than the value of that variable. Whenever that's the case, in other words, I need to know that that's the maximum age. I don't necessarily need to know what the value is. If I need to know that that's the maximum age, then that's where a constant comes in. Okay, so if you're outside the acceptable range, I need to put out an error message of some sort. Now, error messages are kind of cool. We're going to go over some rules, so I'm just going to start typing one, and then we'll go back and catch the rules. Now, instead of doing system out, I'm going to do system error. That's the system error. So error messages are really designed to go with system error rather than system out. Just saying. The rest of it's the same. It'll still be the same printf guy. Okay, right? So our print ln guy. And I'll say invalid value for age. Okay. Now, if that's not the case, then I'm going to say else, and then I will say we're done. Okay, so if you're outside the range, I send you an error message. If you're inside the range, well then we're done, right? So I need to say, are we done? So are we done is equal to true. Cool, that makes sense? Okay, so let's just try this to see if it works, see how this thing behaves. Okay, so let's do, I don't know, 2 again. And we'll do 100 and, well, okay. Well, then we'll do 25. They made really poor scores. And so here I do a 10 and a 25 and a -1. And this is enter your age. And I say -4. It says, no, man, invalid. Ooh, that made it come out red. Isn't that pretty cool? Oh, so it's prompting me again. Okay, fine. 400. No, man, that ain't right. So the only way you can get out of this loop is if you give it a legitimate age, and then it's happy. See how this thing works? Now, let's go back to the rules. Boy, you better be picking up your paper and pencil whenever I say rules. What are the rules for an error message? All right, the first rule is you need to tell them what went wrong. That's fairly obvious. Invalid value for age. Yeah, I guess that's kind of, sort of. Not exactly helpful, because you really need to be telling them, not in addition to what went wrong, how can they fix it? So we're going to be a little bit more, yeah, I'm going to change this to a print F guy, because we're going to need some stuff. Invalid value for age, and then I say the valid range is D is between, I'm going to do D and D. And then I'm going to go down to here and add something things. So this would be min age, right? And max age. Now that's better, because now it's going to come back and say invalid value for age, the valid range is between 0 and 140. So I'm telling them what's wrong, and I'm giving them a hint on how to fix it, but I'm not quite done yet. I also probably want to say something like, please try again. Okay, now I've told them everything. I've told them what's wrong, how to fix it, and what to do next. That's what we need to tell them. What's wrong, how to fix it, and what do I do next? All right, so let's try this. And now they're, whoa. Oh, I don't have a closing parentheses here. That'll slow you down. Okay, fine. I got 2 students with, oh, wait, how did my cursor get way up there? Jeez, I think I messed it. Hang on. Let me just do undo, because I don't want to mess things up. Okay, cool. Now let's get down to here. Shoo. To, I don't know, 33 and 34. Okay, cool. And then I have a 33 and a 34. And then it's going -1 rather, sorry. Okay, now enter front age. So I'm going to say -4. Now it comes back. It says invalid value for age. The valid range is between 0 and 140. Please try again. Now that is an error message. What went wrong? How do I fix it? And what do I do next? Now, there's a 4th rule that you could apply. It's not really applicable here, but later on when we get into the graphical user interface, the 4th rule is you need to tell them where the error occurred. Because in a command line, I know exactly where the error occurred. Error occurred when I typed in the -4. But in a graphical user interface, it may not be as clear where the error occurred. So you might have to tell them where. Okay, that's not applicable here. So right now, we only have 3 rules. What went wrong? What do you want me to do? And what do I do next? Or how do I fix it? And what do you want me to do next? Okay, all right, that kind of makes sense. I like rules. All right. So, The next thing we're going to talk about is how to make a loop basically stop. Okay, how do you... I'm on a merry-go-round and I want off. How do you get off? Well, there's two ways you can get off on a... I guess I need to go ahead and enter this so I can stop this guy. Hey, can I show you some cool stuff? See how this thing is... Remember the little red line? When if I ever come down to print this guy, it's gonna go off the edge. So can I just go in here and just like put a character turn here? Look what it did. It went ahead and closed off the quote, put a plus sign in there, and then I could just do it again. I could put one right here, and so now it wrapped those lines so that they're all. It's still logically it's still all one line. It's just that they made it pretty for me. Isn't that pretty cool? Okay, so let's go back to one of these other loops. Well, I'll tell you what, I won't even demo. This is a pretty simple thing to think about. Okay. A break statement means I want outside of this loop. Doesn't matter what loop it is. It's a while loop, a do while, a for loop. Doesn't matter. Any one of those loops. And I say break. That means I want to exit right here, right now. A continue statement basically says I want to skip all of the code from where I'm at, all the code down to the bottom of the loop, and just go to the next one. So if I'm going through 1 through 10 and I hit continue and I'm on number 4, it'll just skip all the code and go to number 5. That's what a continue does. So continue basically says, look, I want to stay on a merry-go-round. I just don't want to do all this stuff that you told me to do when it comes time for the loop. So it just skips the guts, the stuff in the curly braces. Skip the guts. Okay. On page 229, we talk about how to decide what kind of loop. And yeah, this is important. This is definitely going to be on the quiz. So a counter-controlled loop, that's the one that uses numbers, right? Counter-control, like where I'm using like a loop control variable that's an integer. That kind of makes sense. So a counter-control, a while or do while. So they use numbers as a loop control variable. You know in advance how many times they're going to run. And for most scenarios, there's no real advantage over this versus a for loop. I mean, no real advantage. The for loop, to me, is a little bit more concise because I get to see all 3 parts of the loop all in one line. A sentinel-controlled while. Okay, a sentinel-controlled while, the loop control variable can be anything. It could be, Bob. Every time you type in the word Bob, I want the loop to stop. I mean, right? It doesn't have to be numbers. And a sentinel-controlled while means I don't know how many times it's going to run, and it's quite possibly they won't run at all. A sentinel-controlled do while, same thing. The sentinel could be anything. It doesn't have to be numbers, although in our case it's been numbers in every example. And I don't know how many times it will run, but I know it'll run at least once, okay? And then the for loop. And the for loop is clearly just numbers, okay? And I do know in advance how many times it's going to run, and I shouldn't mess with the loop control variable inside the loop, inside the body of the loop. Okay, one more time. Counter-controlled. Counter-control means the loop control variable is a number, right? Sentinel control, it could be a number, doesn't have to be. And there's 2 different types of sentinel ones. The one that's a pre-test and one that's a post-test. And then the for loop, which is basically the same thing as a counter-control while. It's just more concise and put in one spot. I typically don't use a counter-controlled while just because the for loop does the exact same thing and it's a little easier to read. So I'm just saying I don't ever use it. But that's just me. Okay, so go over that section on page 229. I kind of went into a little bit more detail than they did, so that would be a good opportunity for you guys to check the notes. Okay, we're coming up on the 15-minute mark, so you guys know how this works.